Hello, everyone. Thanks for joining this session. My name is David Santos, and today we're going to talk about NSX ALB, NSX Advanced Load Balancer. So, what is NSX ALB? It's a modern application delivery controller. It's an ADC. It provides server load balance and also global load balance, GSLB, WAF, and analytics. It's a multi-cloud, multi-platform solution, so it can be deployed on-prem or in the cloud. It's elastic and very scalable, so you can grow it as you need. And it was formerly known as AVI. So how does it work? It has a management plane where the controllers reside. Through the controllers, we do all the configuration and also the integration with other solutions like Terraform, Ansible, or any other solution. The data plane, we have the service engine, so the load balancers. Here, the load balancer service will be performed, and the service engine can be deployed wherever the environment is. So it can be deployed at the VMware environment, also in AWS, Azure, GCP. It can also be the Ingress controller for your Kubernetes or OpenShift cluster. It can also be deployed as a bare metal solution, so it's very flexible. And also, if your application needs more performance, more service engines can be deployed as needed. So some demo concepts before starting. The load balancer service will be hosted by our service engine. So our service engine will be the load balancer, and our VIP, our service, will be configured as a virtual service, VS. So to start, we're going to do some hello world. We're going to configure a VIP called demo region 01a.corp.local. Our backend service will be the Web01A and Web02A, and we're going to do some load balancers test. To create a VIP, we're going to select create virtual service. We're going to go with the basic setup, choose a name, demo, choose an IP address. We're going to pick one from the pool, choose a network to deploy the VIP, and also create a new DNS entry. Select the servers. As it is integrated with VMware, we can see all the vCenter portfolio and look at our backend servers, Web01 and Web02. We can also change the pool settings. So go to the pool settings and change the load balance algorithm. Also check health monitor or the persistence method. Here you can see that our application is already working and a DNS entry was created. So we can see that's being load balanced to Web01 and Web02. The next step will be the analytics part. So Avi can take a look at every request. So it provides the error codes, the headers, and also details through on the connection. So for this test, we can see here that some NSX logos are not being loaded, and we select here our virtual service. And if we take a look at all the requests, we can see here that there are some 404 errors. We can take a look at the NSX PNG error here, and you can see that it's not being loaded. It has a 404 error. If you look here at the server IP address, you can see two IP addresses at the backend. So let's drill down a little bit, choose the nsx.png, and now we can see that only the server ending 12, the IP address of 12, has this error. So we're gonna do an SSH to the server and correct the nsx.png name in the file. If you do some more tests, we can see that our application is working fine right now. And we can do a double check here, accessing a request with the nsx.png and response code 12 for the server Web02. The next part will be the scale out. So imagine that your application needs more performance. So more search engines can be provisioned automatically or manually as needed. For this test, we're going to provision it manually. So here you can see that our application is working. We go to our virtual service and choose to scale up our application. We can see that only a single search engine is being using right now. We can do it automatically, or if you want, we can create a new search engine to load balance our application. While the scale up is being performed, no impact to the application is happened. You can see here that our application has been scaled up and the application is working. Avi also has a native self-healing capability. So if failure happens, it will notice that failure and create a new search engine to fix the issue, to fix the problem. So in this demo, we're going to see here that the application is working fine. It is using two search engines in the search engine pool, and we're going to simulate a failure. So one of the search engines, we're going to power it off, and also we're going to delete it from the environment. So that search engine doesn't exist anymore. It's gone. We can see here that our controller already noticed that something's wrong. However, our application is fine. It's still working. No impact to the application. Right now, the controller is deploying another search engine at our environment. We can see here the details about what's the server in which server that search engine will be deployed. And after a few minutes, that search engine will be ready to go. During all this process, the application, the VIP is still working, and there's no impact to the application. We can see here that now our virtual service has two search engines, and our VIP is operational and okay. The next step is the global server load balancer test. So we have already our application at site A, our demo application at site A, and also there's a demo application at site B. And we're going to configure a GSLB service at the URL demo.gslb.corp.local and do some load balance tests across sites. So here we can see that our application at site A is working fine. We're going to do the same for site B. Our application at site B it's also looking fine. And we're going to configure a new GSLB service. So create a GSLB service, choose it, name it. It will be called name.it.gslb.local. Choose a health monitor, and also select the pool members. So demo at site A, and also demo at site B. I'm gonna save it. We can also change it, the numbers of IP address returned, and change the TTL time. After a few seconds, our GSLB service is ready, and we can do the test. Going to our URL, our request was load balanced to site B. And if you do a dig at our URL, we can see that our request is being load balanced to site A, and then to site B, to site A, to site B. If you simulate a failure, disabling the service at site B. And now verifying that using dig, we can see that after a few seconds, only all the requests are going to site A. So, and now if you go through Chrome, we can see that our requests will be load balanced to site A only. If you want to take a look at the status of our GSLB service, we can see here that the service at the site B is disabled. To finish, we're gonna do a demo using WAF, Web Application Load Balancer. So we have a VIP called Hackathon region 01a.corp.local, and the server backend pool, Hackathon, has two machines, Hack 01a and Hack 02a, and we're gonna do some tests using WAF. So the VIP is already created. We're gonna create a WAF policy, choose a name, so Hackathon, choose a WAF profile. I'll stick with the standard options here, the full options, the full signatures and everything. I'm gonna save it and test our application. It's working fine. If we simulate a cross-site script, it was a success, and also a SQL injection simulation, it was already a success. And if we try to access the page using the IP address instead, the URL, it also worked. And if you do a remote code execution, we can take a look at some files inside our backend servers. If you take a look at the logs, we can see here that all those requests were flagged by our WAF policy. We can see here the protocol validation failure, that someone is trying to use the IP address instead of URL. We can create an exception for that if you want. And here we can see some other stuff like a remote code execution that we definitely don't want to happen. So for this case here, we can change our WAF policy. Right now, our WAF policy is in detection mode, so we're gonna change it for enforcement. And we're gonna select error page. If we do the test again, we can see here that our requests are being blocked. Okay, so if you want to learn more, we can check at aviworkshops.com/webinars. We can also try the Hands-on Labs 2137. It's one of the best hands-on labs that I've already tried. And on November 18th, we're going to have an Avi Live workshop. If you have the time, please join the workshop. That's really cool. So thank you very much for attending this session. See you next time.